And welcome back, and happy Arduino Day. March the 16th, 2019 is in fact Arduino Day, and I for one am very happy that they decided to develop this board and indeed make it open source, because if they hadn't, you probably wouldn't be seeing these things on my desktop here right now. Now, if the title of this video hasn't given it away, this is all about Wi-Fi connecting to the Internet of Things, because I'm working on a project. And I thought the very first stage of that project would be connecting one of these boards, well this one here in fact, to the Internet of Things, some kind of cloud container where you can upload your data, ideally for free. Obviously there are many paid programs out there, but I wanted a free one, don't we all? And I found one. So I'll show you exactly how I've done it. And it took me longer than I would have expected because I really wanted this to be secure. That is, HTTPS connection to the internet, whilst I doubt very much whether anybody's eavesdropping on my Wi-Fi. It's just, you know, why would you use HTTP when you can use a secure socket layer? So that's why it took me a little bit longer. Now I've got it on this big Wemos D1 board here because I happen to have a couple of these. They're nice and easy for sort of developing stuff and plugging in stuff to the headers. Whether it stays on here eventually in a few weeks or so when I complete my project, I'm not so sure, because remember I did a whole video, that one there, look, on the Wemos D1 Mini, which is this one here. So look at the size difference, and on top of that one I can plug, for example, this tiny little miniature screen, which is always good for debugging and stuff like that. And I think, yeah, I don't know. And then of course there's this Lowlin here. That's smaller, sort of nano-ish size. I'm not sure if there's an advantage really in going with this size compared to that one over there, because I will be plugging a couple of things in, but not many. It's going to be mainly LEDs or a screen. So if I'm going to use a screen, this one's already built in, isn't it? Now, if you've got an Arduino, and given that this is Arduino Day, I think, well, if you're going to use an Arduino, you'd need something like this. Now this is in fact a hardwired LAN shield, so you'd actually put a LAN cable in there, but of course if you want to use a Wi-Fi shield for your Arduino, it'd probably look something not dissimilar to this. And it always seems a bit of a pity to me that you use a whole ESP8266 just for the Wi-Fi bit, when you might as well just use the ESP8266 natively. One, you can store more in the memory there. Admittedly your programs are larger, but then it's got more memory in the first place. It's quicker, and it can do everything that the Arduino can without any mucking about with shields. So yeah, I know we seem to be coming very slowly to the end of the road with a plain Arduino, other than for very simple projects. Oh yeah, that's an ESP8266 sort of development board, I suppose you'd call it. We can just play about with that. I did show that one as well. Breaks out all the pins. You can plug that into a breadboard and get access to everything. Very nice it was too, to play about with. Oh yes, and if you're using a Nano, Arduino Nano, then this is the shield you need. It's another LAN one. I don't remember seeing a Wi-Fi shield for a Nano, but I may be wrong. But then again, I haven't used shields like that for Arduino stuff. I tend to go straight for the Wemos. So that's where we're at today. We're going to be talking about Wi-Fi Internet of Things, how we connect this up, and I'll show you a very simple demo sketch written in C++ using the Arduino IDE, except I'm not. I'm using a different IDE, but it makes no difference. Just how we can upload stuff, and I'll talk you through the steps. Okay, let's get going. So the first thing you've got to decide is who's going to store your data up in the cloud. Now, I went through 2 or 3 different providers, trying a few things out. I gravitated towards Adafruit initially, but I didn't have enough success with that to warrant carrying that on. I'm sure it works absolutely brilliantly, and they give lots of examples, but I just wasn't comfortable with that. Eventually, as you can see on the screen, I went to Thingspeak, which has been around an awful long time. They do give examples, and in fact there is a library for it for the Arduino, or rather for the ESP8266 chip, which ironically I'm not using, and I'll tell you why when we get to the code bit. But Thingspeak for very simple type projects is free, which is always a good thing. And it's easy to set up your channels, as they're called, and then your feeds into the channel, your data feed into it. It's very simple. In fact, let me show you one right now. This is my channel, and as you can see, it's IoT experiments. And here's a little chart. When I say little, I do mean little. It's difficult to get it bigger than that, or I have fiddled it to get it bigger. And here's another little widget that you can add to say, okay, what was my last reading? And that's all working great, and it just didn't take that long. I'll walk you through the steps very quickly in a minute. Now, you can view this chart on a phone. There's an app for it. It's not the best I've seen, because you've got to hold your phone in landscape mode to see this, otherwise it gets truncated. It's obviously designed for that. But that's some way down the line. I'm not really interested in that. It was getting the data into, well, Thingspeak and into my channel so that I'm tracking it. And this is live tracking. That board on my workbench is in fact sending out something every hour, and in fact there's another one identical to that hanging up behind me on a power supply, literally hanging up, and that's also sending out something every hour. So I've got two boards that I'm experimenting with at the moment. So what I'm doing then is getting 2 readings per hour, and as you can see there, look, it says 8 o'clock was the last one. What's the time now? Oh, it's 9 o'clock. There should be another one, another pulse turning up any second now. I think this one on my workbench was like 9:02. Oh, except I disconnected, didn't I, for this video? So probably not going to be 9:02 anymore. Doesn't matter. How do we get a Thingspeak channel then? Well, the first thing is when you get onto Thingspeak. So all you do is go over to the sign up button over here. It says sign up. It goes blah blah. This is what you need to do, and it goes, have you already got something? No, you haven't. So you just fill in your data here, and off you go. First name, last name. It'll ask you a few details, but nothing onerous. And well, that's it. Then you get back to your channel. Let me show you mine. So this is what my channel looks like when it's been created. Nothing particular about it. Just click on the actual channel name to get into it. You can have many channels, as I say. And here we are. So it goes, here's my channel. Here are my charts that I've created. Now, to create any of this, you need an API key. That is to say, keys that allow you to write and read to a particular channel via a feed. So these are my keys, which obviously I'm going to try and blur out because I really don't want people fiddling about with the data on my channel here. So if I open this up, so here we are. Here it says, right, this is your write API key and this is your read API key. I haven't actually used the read one yet because I think that might come in useful when I'm reading stuff down to an app, say, on a phone, or back down to the ESP8266, whichever, I'm not really sure. But I've used the write key. And here it says this is how you format your requests, but leave that to one side for a minute because I'll show you the way I did it, which is slightly differently. Okay, and remember, we're talking about doing this from an ESP8266, not some app on your Android or Apple or whatever. Okay, right, so all your channels at the moment will be private, and if you want to make them public, it will tell you go to sharing, and then you can type in the email addresses of anybody you want to make a particular channel public with, so they can view your charts and what have you. And I'll be doing that sometime in the future. Right, back to the private view. Okay, so how did I get this data up here? So here's a list of all the fields and the stuff on my channel. The channel ID I think is pretty public. That's not kept secret from anybody. Nor is the name, nor the description. Here are all the fields, so field 1 to 8, and you tick them to say, yes, I do want these. And, well, there's just some other information that you can fill in, and I'd probably fill that in closer to the time when this actually gets launched as a proper application. And then you save your channel, simple as that. Now, I'm only using one field, as you can see, for temperature at the moment, just to prove that it's working. But I say you can have many more. Let's show you a bit of the code then now, how we connect to this. Having created all this up, and you go, yeah, I've got it. What will happen to you, of course, you'll go to your private view, and there will be no data. It'll just be nothing, blank, because you've not uploaded anything. Now, you can add data manually via data import export. and it goes, okay, where's your file then that you want to import, so you can get some data up there just to prove that you can see it. But frankly, if you get your ESP8266 code working, well, basically paste my code in for now. It's just pseudo data, it's not real temperature reading, it's just a random number. You'll be able to see something pretty quick. That's what I did. I got this bit just up and then uploaded some random data, and it all seemed to work. Right, let's go back to the code then. Right, this is the demo sketch then that I've put together. I say demo, it's probably going to be pretty close to what I'm going to be using actually. So it's ESP8266 based, which means you can put it into the Arduino IDE. Yes, I know this isn't the Arduino IDE. I prefer to use the Eclipse Slurber version, which is okay. It's just a lot of hard work. It probably took me a whole day to get it to work with ESP8266. Up to that point it was working fine with Arduinos, but I've always had trouble with ESP8266 in this version. I don't know why. Maybe the newer version, I think this is 4.3, maybe it just works better, but whatever. Anyway, it took me a little while, so I'm not going to explain how I did that. Put this into your Arduino IDE. Make sure you got the additional boards set up from your boards manager, ESP8266, and just, well, you can paste this in really, it would work. So let's go through it, not quite line by line, but certainly, you know, I'd like to do it reasonably detailed. So what have we got then? Well, at the top it just describes pretty much what this whole sketch is about. Okay, I have to include Arduino H in here. That's just because I'm using this Eclipse version. Now, the secret stuff, like my API keys, which I really don't want to expose to the world, and my password for my Wi-Fi and all that, are all in this file here, config.h. You could call it secret.h, you could call it bugsbunny.h, it doesn't matter what you call it, as long as you include it in this sketch, your stuff will be in there and it's secret from prying eyes if they ever look at it. Now I've got a demo.h, config demo.h here, just so you can see what it's like. Right, so what this is then, so the first few lines at the top here, so where it says if endf, it says if I haven't defined config.h, let's define it now. This prevents you including it more than once and overwriting your own variables. It's just something that happens magically in Eclipse. You do not need that. All you need to put in are these define statements. Now these keys that you see here, these are the ones that you saw on the Thingspeak page. Just copy them in there like that, and then your SSID for your Wi-Fi and your password, put them in there as well. Obviously they're not my ones, but they could be. And that's it. And any other secret stuff you want in there, all right? It's just a header file at the end of the day. So then you can include it in your main program like this, and all the stuff is just magically sucked into it. Great. Okay. Now we are using ESP8266 Wi-Fi, so that's where we need this header. Make sure you get a reasonably new version of that, because things have changed. And I think it might now be up to version 4.3, 2, possibly even 5. But anyway, maybe what I'll do is put my version of this library up on my GitHub, so at least you've got the exact version I've got, and therefore you won't get compilation errors if you happen to have chosen a different one on your machine. Right, now I'm saying there's a Wi-Fi timeout and an HTTP timeout as well. So basically, can I connect to the Wi-Fi? I can't after 10 seconds. I'll just forget it and try again later. And ditto for connecting up to the cloud, in this case, Thingspeak. Now, password here, this is where we're dragging them in from the config file. Oh, nice and easy. And basically, your right API key has to be defined as this character pointer, and the server as well. Just, this is all taken, well, a lot of this is taken from their examples, but I haven't, as you can see, used their Thingspeak library. So this is where we're going to, api.thingspeak.com. That's fine. And this is the path update, and this last bit is the parameter. So we're saying API key equals, well, as we know, it's field 0, or was it 1? Can't remember. We'll come to it in a minute. Does it start at 0? Everything starts at 0, doesn't it, in computer world? Right, the setup then basically says go and connect to my Wi-Fi, and seed the random number generator, because all I'm doing here is uploading random numbers purporting to be my temperature, right? I've not connected any sensor to this. There's no point, because I'm not actually going to be measuring sensors. It's something else I'm going to be doing. Oh yes, serial.begin. Now I've used 76800 here. Why have you done that, Ralph? Glad you asked. When the ESP8266 starts up, if you're not using that baud rate, you'll probably get a load of gibberish on your screen initially before your proper serial output springs into life that you've written. But I thought, no, I want to see everything running, and I'll show you what I mean in just a sec when we check this out over here. Right, what does connect to Wi-Fi do? Well, that's just down here. That's this little routine. It's the standard one. You'll find thousands of examples like this all over the internet, and it's just a way of connecting to your Wi-Fi. Okay. I'm not going to go through that because there's so many examples out there. You just don't need me to go through it. The second thing is, okay, random that. Don't need to do any more. Now in the loop, we're saying upload some data to Thingspeak via HTTP and then do this big, long, massive delay for an hour. So what is the update data via HTTP? That's the crux of this whole sketch, isn't it? So let's have a look at that. Now, I have mentioned here about we want to connect securely, and there's details here on how to get the fingerprint of the certificate for thingspeak.com, api.thingspeak.com, right? The certificate is the secure certificate, and in your PC world, whether it's PC or Mac, you hold in your PC dozens of certificates, top level domain certificates that say this is the valid certificate for that site, and it's hundreds of kilobytes. Well, we haven't got that space or luxury to do that. So all we do is say, give me the fingerprint, which Chrome browser will give you, hold it locally. So when we connect, we say we're expecting this fingerprint to be on that site. So let's step through this. So we're using a Wi-Fi client secure. Okay, so that means HTTPS client. But just having an HTTPS client is not enough. You then got to say, set the fingerprint to the site I want to connect as this big long string, which is the details of how to get it in here. Chrome will give it to you. And then we say, right, we're trying to connect now to our server, api.thingspeak.com, on port 443 instead of port 80. 80 being HTTP, 443 being the secure one. Okay, so I whiz around here and say, well, I've tried 5 times. I couldn't connect, so I'm, well, it says going back to sleep. What it should really be there is exiting. Okay, because it couldn't connect. It will try again in a few seconds' time. But let's assume it has connected. We're creating a random number that pretends to be our temperature between a range of 2 and 100. And it says on the debug screen what it's going to do. Now here, this is how we construct the request to that website, and it's a GET request, even though unintuitively it's going to update something at the other end. Now all those programmers out there, you'll go, well, why aren't you using POST? Well, you can use POST, but the example they showed was using a GET, and I thought, well, it doesn't really matter really, it's encrypted now. POST basically puts the data into the body of the message you're sending rather into parameters that you can read across the URL line. Okay, but this is encrypted now, so it doesn't matter. So this is how it creates the string, and our key, the very value we're updating, we're saying field 1, oh it is 1, not 0, there we are, is our random number, which I've converted to a string because that's what it expects, right? So that's what we're trying to send to our client for the client.print statement. And then we wait for some kind of response for, in this case, 10 seconds. Right? The HTTP timeout is 10 seconds. No, it's 5 seconds actually. But we're trying it 10 times a second during that period, because obviously the response could come at any instant. Now, if you don't get a response, it's just gone off into the ether somewhere because maybe their website's down for a bit, or there was something wrong with your Wi-Fi, or a bulldozer's dug up the cable in the road, whatever. It would just say, well, I didn't get a response. And it says, right, I'm going to exit now, and you get this error message. I have never had that. It's always connected. So let's move on and go, right, let's display the response now. All the gobbledygook you get back from a GET message about how did I connect, was it successful, what are the headers of the response and everything else. I've just displayed them for debugging purposes. Normally you just discard these, we don't need them. We're not after all displaying any kind of web page out of this. So we're displaying all that within this block here, and then we're closing by the stop our connection because we don't need to keep it persistently open. And as over here, I'll take myself off here because it's behind my head. Right, this stuff you see over on the right hand side, all this is what you get back after a successful send. So if we go, so that was the end of the previous close of the connection. It says now I'm connecting to API thingspeak.com, and obviously things went okay because there's no error message, because I'm sending sudo temperature value 31. I'm now actually issuing that get command that we strung together. All right, and then this is all this in here is what comes back as part of the server response, and the most important part of all that is this response here. 200 in HTTP world means everything was all right. If you get a 404, it means it couldn't find where you were going to, which is highly unlikely. If you get a 500, it means something went wrong their end. 403 means it was forbidden, probably something on your API site. Lots of this stuff is on the Thingspeak documentation and support pages, all the error types of error message. Okay, now if you were to use their library instead of this code, then they deal with those error messages and send you something back via the debug window that is a bit more meaningful perhaps. So you can have a look at those and see whether you'd rather have it unencrypted but more meaningful, or a bit obtuse like this lot here but secure. Maybe you could start with the unencrypted and then move over to the encrypted as you get experience of doing it. Right, I think we just need to see one little live demonstration of this. So we're going to keep this code running here, and in the same screen I'm now going to bring up the Thingspeak graph so you'll see it actually update in real time. Okay, right, so what I'm going to do is reset this, which will basically start that entire code we just looked at all over again. Now what you need to look at is this bit over here, because this will update. Let me clear it. Right, we lost the contact there just for a bit. Let's restart this again and see what it turns out. So watch this window here, so that'll be the debugging, and watch the graph to see if anything else appears above that one there that has only just been sent out, because when I press reset nothing appeared on the debug window. So let's have a look what happens. There we are, it's trying to connect, and well, it says it's done it, and it says it's sending 69 as the temperature. So what have we got over here? That's 60, there it is, 69, 949, and it is 949. So in fact it was more instantaneous than I thought it would be. Excellent. Now if you go back to the, at this point this is just the graph I'm looking at. If I go back to the Internet of Things here and scroll down with a little tiny graph in it, you see that. You'll see this hasn't updated yet. This seems to be a lot slower. That's got the 8 o'clock one, and that's it. So let me force a refresh and see if it actually does it. Alright, that's updated something. So what's the last one it's got? 64 at 9:30. I think there's a couple of points there actually. They're too close together now. I can't get my mouse over, which is why when you click that button there it brings you this, but I don't want to click it because I've actually hacked the code behind this to make it bigger for demo purposes. I know the trouble I go to, you wouldn't believe it. Right, so what we've proven then is this ESP8266 connects to api.thingspeak.com, it connects securely, and it sends the data and it's updated pretty much in real time. Brilliant. Now yes, this could be a temperature. Yes, it could be humidity. It could be water levels. It could be anything. The point being, though, you can then connect via your phone or something to thingspeak.com and just have a look without doing anything else, without making it, you know, all fancy and pretty and everything else. You want to see that? Well, I can show you on my phone very, very quickly what it looks like, and then I think we'll call it a day. Right, here we are then, looking at my phone. I've logged into Thingspeak. This is actually ThingView app I'm using now, but it has to connect to Thingspeak. And this is the graph that you saw. This is the free version, hence why we're getting adverts down the bottom. And it says the last value in the middle was 69. And you can touch any of these values on here, although with my fat stubby sausage finger it's quite difficult to do, but you get the idea. And if you turn your phone, it will make it a little bit more legible. I've got my auto rotate switched off, so let's switch that back on. And what does it do? There we are. So now it becomes a little bit more legible and you can see things a little bit better. Unfortunately, the advert down the bottom is taking up a little bit of space, but you get the idea. I mean, without doing much at all, we've already got something up in the cloud that anybody can then log into this, as long as they've got your API key and password, login password. It just works. I mean, that's pretty good, isn't it? Now, I don't know whether I'll be keeping this particular app to look at my data. Probably not. I'll probably write my own. That's something for the future, though. But in the meantime, this is helping me debug stuff, and of course you get an instant view of what your last data point was, because there it is, bang in the middle of the screen. Pretty good. So there we have it then, a very, very quick introduction into getting stuff onto the internet, the cloud. And then, quite frankly, it was a bit easier than I thought, even though it took me a little while to do. But as I say, that was my own fault for trying to get this to connect in a secure manner. But now I've done it, I think, yeah. Now the library that you can get, the Thingspeak library, is available, and I would say, yeah, go for it. Play about with that first and get a feel for how it's all going to work. Let me show you that. So here's the library that they've put up onto GitHub. You can just pull that down. Clone or download, so you just download it as a zip, unzip it, and then stick it into your libraries folder in your Arduino sketches folder. It's a subfolder of the Arduino sketches. As I say, it works as it should do as far as I know, because they wrote it, and but it's not secure. Maybe they will update it to make it secure in the future, I don't know. You can also make Thingspeak do stuff. So for example, look here, you can get Thingspeak to tweet you if on a particular condition. So for example, if the temperature that I'm registering goes above 50, for example, it could tweet me going, "Oi, your workshop temperature's above 50, what the hell? Something's going wrong there." Probably on fire, actually, if that happened. But anyway, you get the idea, all right? And I'm looking at to see how we can perhaps link that up to WhatsApp, which would be slightly more useful in my case. If not, I'll fall back to email, which I've done videos on in the past, how to send email. That is particularly easy. So I might start off with emails first, just to get the proof of concept out of the way, and then move on to either Twitter or WhatsApp. There's so much to do, but this is the first steps. So I hope you've enjoyed this journey, and I'd highly recommend that you go out there and just take my sketch initially, if you like, and get a channel on Thingspeak and just do it. Because once you've done it, then the possibilities in your mind start opening up and go, now I can do this, but what if I do that, and can I log this? And that's how it all happens. That's how projects start building. All right, great. Right, I hope you like this. Thanks very much for watching. Put your comments down below, and if you've got any suggestions about where else we can use this type of technology, do put them in there, because other people read those comments, of course, and that triggers off thoughts in their mind. Okay, and don't forget, give me a thumbs up, because YouTube likes it. All right, they like thumbs up, and they like comments, and they like you watching the ads. Believe me. If there are any links to actual products, which I don't think there will be in this video, but if there are, they may be affiliate, and they may help this channel stay afloat. Okay, great. Thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.